Now in this section we start derivatives of some standard composite function. Which function? Derivatives of some standard composite function. So here I am taking some formulas which are very important for solving next problem. If you recall very well, then you will very easily solve problem on depends on derivative of composite function. So here y is equal to some functions f of x raised to n, root f of x, 1 upon f of x raised to n, sine of f of x, okay, etc. Then how to find its derivative? Here I am showing that some techniques which are very common and repeatedly, okay. So here we start first function. How to find its derivative? Remember, these are all functions are which function? Composite function. Here we see that sine of f of x, not here sin x. Sin x means simple function, but here is not coming sin x function. Here is coming sine of f of x. Means it may be chances here is some other any other functions. Sine of log x, sine of tan x, sine of cot x. These are all functions are called composite function. Here lots of probability. So we finding in general formula. If you apply any formula which looks like this form, okay. So therefore we finding first formula f of x raised to n, f of x raised to n, which looks like which form? X raised to n form. So what is x raised to n derivative? N into x as it is n minus 1. Which derivative? X raised to n derivative, n as it is into x, but I am not writing here x. Why? Wait. Into n minus 1, okay. But we don't want to find x raised to n derivative. We want to find x raised to n form derivative, which looks like x raised to n form. But here is not x, here is f of x. Means sin x raised to 4, sin x raised to 10, cot x raised to 5, but which looks like x raised to n. Therefore, but use which formula? X raised to n formula use here. Just some techniques are different. Here x is replaced by f of x. Therefore, then how to find f of x raised to n derivative? By using composite. Our composite function theorem says that first differentiate y with respect to u and differentiate again u with respect to x. So first of all we want to look which form? X raised to n. Then use first formula x raised to n. What is the x raised to n formula? N in bracket x raised to n minus 1. But here is not x. Here x is replaced by f of x. Multiply. Which function? Use derivative. What is meant by u? U means any other function. U means here f of x. So multiply. Use derivative means f of x derivative. So here multiplying we f dash of x. Note that f dash means also derivative. Therefore that's why I am writing here dash symbol. So what's derivative? F of x raised to n. N into f of x raised to n minus 1. Multiply f dash of x. Okay. Then second function look like which form? Which looks like root x form. What is root x derivative? Root x derivative is 1 upon 2 times root x, okay. But here is not x, here is root f of x. So we use only root x derivative, but by the way x is replaced by f of x. Root f of x derivative 1 upon 2 times root f of x. Multiply f dash of x. Then third function 1 upon which form? F of x raised to n form. Means 1 upon which form? X raised to n form. What is 1 upon x raised to n derivative? Minus n upon x raised to n plus 1. So I am writing here this formula same. Only x is replaced by f of x. Minus n upon f of x raised to n plus 1 into multiply by f dash of x. Whatever f of x, then take its only derivative, okay. Then next 6 functions. Here is sine, cos, tan, cot, sec, cosec x. We already very well known that what's its derivatives. So first of all, we are writing only its derivative, plain derivative. Plain derivative means here is sine something function. What is sine x derivative? Sine x derivative is cos. What is cos derivative? Minus sine. What is tan derivative? Tan derivative is sec square something. And what is cot x derivative? Cot x derivative is minus cos x square x, but here is not x. Sec of f of x. Sec f of x derivative. Sec. What is sec x derivative? Sec x derivative is sec x into tan x, but here is not x. So therefore we are writing only sec into tan of. Then what is cosec x? Cosec x derivative is minus cosec x into cot of something function. But in bracket what will happen? In bracket just same as it is. Here is f of x, sine of f of x derivative. First we finding sine derivative. Sine derivative is cos of f of x. Then multiply. What multiply? F dash of x. First we finding sine derivative, cos of f of x, into multiply f dash of x. Here f of x, here f dash of x. Then second derivative, cos of f of x. Cos of f of x derivative, cos derivative minus sine f of x into f dash of x. Tan of f of x, sec square f of x into f dash of x. Cot of f of x minus cosec square of f of x into f dash of x. Sec of f of x, sec f of x into tan f of x. What is sec x derivative? Sec x into tan x. Here is not x, here is f of x. Therefore we are taking sec of f of x into tan of f of x into multiply by only one time f dash of x. These are all depends on composite function formula. Cosec of f of x. Next rule, cosec of f of x. Cosec f of x derivative is minus cosec of f of x into cot of f of x into f dash of x. Then next, a raised to f of x, which look like a raised to x. E raised to f of x, which looks like e raised to x. Log of f of x, which looks like log x. Which look like means we always be taking which looks like example in form. Then take multiplying by derivative f of x, f of x, f of x. So here a raised to f of x. So we are taking a raised to f of x derivative as a raised to x. So what is a raised to x derivative? A raised to x into log a. So what is x? X means here f of x into f dash of x. Then next, we know that e raised to x derivative is e raised to x. So here e raised to f of x derivative is e raised to f of x. Then just multiply f dash of x. The next next example, log of f of x. Log of f of x, log x derivative is 1 upon x. So log of f of x derivative is 1 upon f of x into multiply by f dash of x. Log, next example, log of f of x to the base a is equal to, here is base a, here is not base a, means that log f of x to the base log a. Here log a is a constant function, therefore log a as it is. We want to only take log f of x derivative. What is log f of x derivative? Here we are already finding f dash of x upon f of x. 1 upon log a is constant term. Then we want to take only log f of x derivative. Which one? F dash of x upon f of x. Already we find in log f of x form. So what you observe in this formula? One thing is common. Which one thing? F dash f dash f dash means derivative always. Now how to find derivatives of composite function? First of all, here sin of f of x, we're taking sin's derivative as it is cos of f of x. Then which function is present? Remaining f of x. Then multiply by its derivative. This trick is same everywhere. Therefore, you have to learn very well formulae. If you learn this formula very well, then you will very easily solve this problem. Now here we will learn how to differentiate composite functions problem. Examples on composite function. First question, differentiate the following function with respect to x. Differentiate the following function with respect to x means we have to find dy upon dx. First question, y is equal to x cube minus 2x minus 1 bracket raised to 5. Its solution, let y is equal to x cube minus 2x minus 1 bracket raised to 5. Then we want to find its derivative, but this function looks like which form? Here is the f of x in bracket. What is the f of x? F of x means x cube minus 2x minus 1, and f of x raised to n. Which form? F of x raised to n form. N means here is 5. Then differentiate y with respect to x. Therefore, y derivative dy by dx is equal to derivative of x cube minus 2x minus 1 bracket raised to 5. Which form? F of x raised to n form. Therefore, f of x raised to n derivative is n into f of x as it is into n minus 1 bracket raised to n minus 1 into f dash of x. Therefore, using this formula, n means 5 first, then in bracket f of x. What is mean by f of x? F of x means x cube minus 2x minus 1 bracket raised to 5 minus 1. N minus 1 means n is 5. 5 minus 1, 4 into f dash means derivative. Which function? F of x. What is mean by f of x? F of x means x cube minus 2x minus 1 is equal to 5 as it is, this function as it is, x cube minus 2x minus 1 bracket raised to 4 into derivative of, here is three function. First one is x cube, second one is minus 2x, and third is minus 1. Minus 1 is, here is not x variable present, therefore 1 is taking a constant function. We know that constant derivative is 0. So first is x cube means x raised to n, its derivative 3x square minus 2x, x derivative is 1, minus 2 as it is, 1 derivative is 0. Therefore we get required solution, 5 x cube minus 2x minus 1 bracket raised to 4 into 3x square minus 2. This is the required derivative. Then second example, y is equal to root of x square plus 4x minus 7. Which form? First of all, we have to find which form example is given. I think y is equal to root x form. Which form? Root x form. Root of x, here root f of x. Therefore, we use here root f of x derivative. Differentiate y with respect to x. Why differentiate we always y with respect to x? Because all functions which form? X form. Therefore, we differentiate y with respect to x. Therefore, dy by dx is equal to derivative of root of x square plus 4x minus 7. What is root x derivative? A root of f of x derivative 1 upon 2 times root f of x into derivative of f of x. What is f of x? Here f of x is x square plus 4x minus 7 into derivative of f of x. Again here x square plus 4x minus 7. Okay, this term as it is 1 upon 2 times x square plus 4x minus 7 as it is into derivative of, first term is x square derivative 2x, second is 4x, x derivative 1 into 4, and 7 is constant, then constant derivative 0. Okay, then 2x plus 4 is equal to, if we here 2 is common, if we are taking 2 is common, then remaining terms are 2 times x plus 2 upon 2 times root of x square plus 4x minus 7. Then 2 cancel, then we get required solution, x plus 2 upon root of x square plus 4x minus 7. Therefore this is the required solution. Third example, y is equal to cos of x square plus a square. Its solution, let y is equal to cos of x square plus a square. Differentiate y with respect to x. Therefore dy upon dx is equal to derivative of cos of x square plus a square. Given function look like just like cos x, but here is not x. X means f of x in other function. Which function? F of x means x square plus a square. Therefore here we finding first function is cos x form, cos f of x form. So we directly find cos f of x derivative. What is cos f of x derivative? Cos derivative is minus sine of f of x. But what is f of x? F of x means x square plus a square into multiply by its derivative of f of x. F of x means x square plus a square is equal to minus sine of x square plus a square as it is into derivative of x square plus a square. Here we finding derivative with respect to x. For x, a term is constant, so a derivative is 0, but x square derivative is 2x, therefore 2x plus 0. So final answer is minus 2x into sine of x square plus a square. This is the required derivative. Then for problem, y is equal to tan of cos of sin x. Y is equal to tan of cos of sin x. Here we looking three functions. First one is tan, second is cos, third is sin. Then let us see how to differentiate this function. Solution, let y is equal to tan of cos of sin x. Then differentiate y with respect to x. Therefore dy upon dx is equal to derivative of tan of cos of sin x. Here we see that first function is tan of something. What is something? Tan of something means tan of which form? Tan of f of x. Then take cos into sine, cos of sine x as a whole function means f of x. Okay, then we want to find only derivative of tan of f of x. Tan of f of x. Here f of x means cos of sine x. Therefore first we find tan f of x derivative. Why? Because which looks like tan of something function, f of x, tan of f of x. So we finding first tan of f of x derivative. So tan f of x derivative is sec square f of x into derivative of f of x. What is f of x? Here f of x, then we can find derivative of f of x. F of x means cos of sin x. Then multiply derivative of cos of sin x. Then sec square of cos of sin x as it is into derivative of which derivative? Cos of sin x. Again, what you observe that here is not simple function. Here again comes which functions? Composite function. But before finding this composite function, first we want to find cos derivative, because cos come first, then after multiplying sin's derivative, because sin x is a composite function in between cos. Therefore first we take cos derivative. Cos derivative is sin of f of x. What is f of x again? Here is new f of x. Here is sin x into again derivative of sin x. Why? Here is cos of sin x function. Therefore we are taking cos derivative sin of function. Which function? Sin of sin x. Then again taking derivative of sin x derivative. So next step is sec square of cos of sin x as it is into sin of sin x into derivative of sin x. Here sin x is a simple function. We know that sin x derivative is cos x. Therefore this is the required whole solution. Check that if there is any changes possible. Then here is sec square of cos of sin x into sin of sin x into cos x. There is no changes. Therefore this is the final solution. Dy upon dx is the required solution. Then next example, fifth one. Fifth one is very important. Y is equal to log of first function tan cube x into sin raised to 4x into x square plus 7 bracket raised to 7. Then how to find its derivative? Which form? Log of f of x. But again here f of x means how many functions? First function is tan cube x. Second function is sin raised to 4x, sin 4x. Then third function is x square plus 7 bracket raised to 7. So how to solve this example? We know that log rule. What is log rule? Log of AB. Log of AB is equal to log A plus log B. If here are three functions, first function is tan, first, second, third, then we use log of which rule? A, B, C, third function. In multiplication, if log of multiplication form, then we can write addition form. What is log of ABC? Is equal to log A plus log B plus log C. Which form? Log form. Okay. Therefore this example we write first of all solving log rule as per log rule. Solution. Okay, directly start solution. Y is equal to log of A means here taking I am A B, C. A means tan cube x, B means sin raised to 4, C means x square plus 7 bracket raised to 7. So log of first tan cube x plus log of B. B means sin raised to 4x plus log C. What is meant by C? X square plus 7 bracket raised to 7 is equal to log of tan x whole cube. Tan cube x means tan x bracket raised to cube plus log of sin x. Sin raised to 4x means sin x raised to 4. Log of x square plus 7 raised to 7 means bracket raised to 7. Here we use which rule? Log of index rule. As per index rule, then here 3 comes. First 3 log of tan x plus 4 log of sin x plus 7 log of x square plus 7. Okay, then we can differentiate. Therefore differentiate y with respect to x. Therefore dy upon dx is equal to derivative of first one 3 log of tan x, second 4 log of sin x, then third 7 log of x square plus 7. Then we know that derivatives of sum formula. Here how many functions? First function, second function, third function. Then we have to differentiate first function plus second function plus third function. By using derivative of sum formula, we differentiate each term separately. Derivative of 3 log of tan x plus derivative of 4 log of sin x plus derivative of 7 log of x square plus 7. Here each term some constant functions are available. Here 3 is constant, 3 into log of tan x. Here 4 is constant, here 7 is constant. Therefore we are taking constant function outside the derivative. So 3 as it is, derivative of log of tan x plus 4 is constant, derivative of log of sin x plus derivative of 7 is constant into log of x square plus 7. Then we have to only find derivatives. So first derivative is log of tan x. Log of tan x means again here come composite function. Then second one log of sin x, then again composite function. Then last one log of x square plus 7, then again composite. Now what is log x derivative? We know that log x derivative is 1 upon x, but here is not x, here is f of x. So log f of x derivative is 1 upon f of x into f dash of x. Therefore first finding we log derivative. Log derivative is 1 upon tan x, then tan x derivative directly. Tan x derivative is sec square x plus 4 as it is. And derivative of log x, what is log of sin x? Then log of sin x means 1 upon sin x into sin x derivative. Sin x derivative is minus cos x plus 7 as it is. Then log of x square plus 7 derivative 1 upon x square plus 7 as it is into derivative of x square plus 7. X square derivative is 2x and 7 is constant, 7 derivative is 0. Therefore I am writing here only 2x. Then just only calculation parts. 3 as it is, 3 into x square x upon 10x. 4, here is minus, then plus is not possible, plus into minus becomes minus 4, cos upon sine, cos x upon sine x means cot x, plus 7 to the 14x upon x square plus 7. Okay, if there is any changes possible then do this, otherwise you will get final answer dy upon dx. This is the required solution, okay, by using log rule. Here I am giving some homework questions on depends on composite function. So discuss, we just only answer hint. Differentiate the following function with respect to x. First one question is root of tan root x. We want to find derivative root of something f of x. What is f of x? F of x is here tan root x. So first of all we want to find the root of f of x derivative, then multiply by its derivative means f dash of x. Here, so here is f of x means tan root x. Then second question, sine of sine root x, which looks like which form? Sine of f of x. So use sine of f of x formula and solve. Here third function is very interesting example, which looks like 3 times log of x and whole bracket square. But this example is very simple. How to solve? First of all, think about how to looks. I think bracket raised to n. N means in number. Here is number, which number? 2. And take whole f of x. This function is whole f of x. F of x raised to n. N means here 2. So which formula is possible? F of x raised to n means its answer which form? 2 times f of x as it is raised to 2 minus 1 means here is 1 into derivative of f of x, f dash of x. What is f dash of, what is f of x? F of x means we finding derivative log of x. Okay, then try it. Then fourth one, log of root of 1 minus cos 3x upon 1 plus cos 3x. Here use formula 1 minus cos theta and 1 plus cos theta. Then check that after calculation some terms are cancelled, then very easily you can solve it. Then last one example, log of a raised to cos x upon x square minus 3 bracket cube upon into log x. Which form? Last example we discussed by using log rule. This problem also solved.